Newton's laws of motion have been thoroughly described and discussed in other podcasts. In this podcast, we discuss the first true and mathematical law of gravitational attraction. It is essentially the story of the apple that fell on Newton's head, and how this analogy created a universal law and a new way of thinking about the universe. At the time Newton discovered this law, the universe was a very small place. As far as we knew, the universe consisted of the sun, the planets, the moon, and the stars. We didn't really know what any of these things were. However, Isaac Newton discovered the law that keeps all of these objects in motion around each other and governs the motion of the very, very big. Gravitation is the weakest of all the forces known to science. It requires extremely large masses to exert a noticeable force. The force generated by the mass of the planet Earth can be overcome by the power of a single human being. You can lift objects off the ground. It was Newton who established that gravity was the force that acted between masses, and that it was a universal law. It was he who suggested that the force that pulls apples to the ground is the same as the force that pulls the moon around the Earth. As had been discussed previously, we can treat masses as points if we find their centre of mass. The force of gravity acts through these centres of mass, and Newton's law of gravitational attraction uses this principle. Newton's law of universal gravitation works in three dimensions. Around a point mass, there is a sphere of space through which gravity works. This is the same of all field-based studies of force. The area of the surface of a sphere is 4 pi r squared, where r is the radius of the sphere. The gravitational force is spread throughout the sphere, giving Newton's universal law of gravitation as the force between two masses being equal to the two masses multiplied together, divided by the square of the distance between them, all multiplied by a constant of proportionality called the gravitational constant, capital G. The distances between the two masses is the radius of the spheres surrounding one of these two masses.